All right, so to clear this up, sorry it took me so long to get this to you. I had to go back and kind of think about periods and how those apply to both sine and cosine. And so let me know if you need if we need to talk about you need something with tangent too. I can help with that one. So like for example, the two things I'm going to look at is we have your example where we have the cosine of -1/4. So we have the cosine of x is equal to -1/4. And then I have an example that I was playing around with, which was the sine of x is equal to, where'd it go? 3/4. Okay, so I'm going to kind of bounce back and forth. So I have another tool that I'll post for you to help, but let's go to our unit circle first and let's look at your cosine question. So one thing that I want you to add to your unit circle printout is that first of all, let's go ahead and add this in. So oops, right pin back. So adding this in someplace on there is that, we have an ordered pair x and y. And so when we look at that ordered pair, basically the cosine of theta is always going to be equal to the x value. And the sine of theta is always going to be equal to the y value. So for example, if you took and said, I wanted to know the cosine of pi over 6. So you come here, you look at this guy, you say the cosine of pi over 6, and so the answer would be the square root of 3/2. And so that kind of applies all around, or vice versa. If you said, I want to know the sine of, and I'll just do an easy one, let's do 90 degrees, so let's do pi over 2. Sine is the y value, so that means that would be equal to 1. And so you can plug that in your calculator and test that one. It's a little bit harder to do the square root of 2 just because they're going to give you a decimal in your calculator. So that's kind of our first foundational piece. I'm going to erase a little bit of this. I'm going to erase this part right here and add on to this conversation. So the piece to add on to this conversation is that, so we have this idea that we know that the x portion is going to be the cosine, the y portion is going to be the sine. Then what I want to add on to that is that if, let's say you wanted to find tangent, tangent of theta, that would just be sine of theta over cosine of theta. So you would just get like the values like I just did, and you'd put the sine on top and the cosine value on the bottom, and you simplify that, give you the tangent. Now what I want to add in here is that as we move around the unit circle, when we think about ordered pairs, in this quadrant right here, if x represents cosine and y represents sine, then that means that in this quadrant right here, we're positive and positive. And so that means that your cosine is positive and your sine is positive. Okay, we come over to this quadrant. My ordered pairs are negative and positive. That means that my cosine is negative and my sine is positive. When I come down to this quadrant, I have, and you can see that it's listed out right here for us on the number on that. We're just kind of explaining that. So this is negative and negative. And so that means that my cosine is negative and my sine is negative. And then we go to the last one, and once again, it's written right here, but just kind of understanding that. So we get to this guy, and we say, okay, in this quadrant, our x is positive and our y is negative. So that means that our cosine is positive and our sine is negative based upon this established piece right here. All right, so now we have that established. We're going to go back and forth from this sheet. So now let's go back to our problem. So we have the cosine of -1/4. So no problem. We plug that in our calculator. We do inverse cosine. So we do inverse cosine of -1/4, and we find out that we get x is equal to 1.823476. All right. Now, to understand the why it's 2 pi minus, or why it's pi minus and so forth, I went and pulled a period graph. So these are they basically have the trigonometric functions laid out in their periods. So what I want you to think about right now is that we had negative, what was it? Negative, 1.82, right? But we know that we're in negative pi. We're in negative solutions. That means we're down here. So when we think about this, we've gone and we're right here. And so we're just going to call that 1.82. Okay. And so the idea is that we plug in our x value. I'm sorry, we plug in our theta and we find our value there of 1.82. All right. Now, the tricky part about this is because this graph is symmetrical, we've traveled 1.82 on this graph right here. And so if we traveled 1.82 to get to that value, and I said that backwards, I apologize. Let's say that's negative 1/4. Okay, so we're at negative 1/4 on here, and that takes us over to negative 1.82 right there, right? Let's move it up a little bit. So now, why on a cosine do we do 2 pi minus that value, minus that 1.82 value? Well, because what we have to do is we have to come out here and say, okay, well now we don't really know the distance from here to here. So we know we have another value here. We can see that at negative 1/4, we know at negative 1/4 we have two values inside of this period of this graph. This graph goes for a period of 2 pi. So what we have to do is understand that to be able to find the distance, since this is symmetrical, we're going to travel that distance backwards, just like we traveled this distance forwards. And that distance forward was 1.82. So to figure out that backwards, we would take 2 pi minus that, I'm abbreviating the 1.82, minus that 1.82, and that would give us that new value. So when we come back to your screen here, and we say, okay, to find our other x, we're going to take 2 pi minus our 1.823476. We pull out our calculator, we say 2 pi minus 1.8246, and we get x is equal to 4.45970, right? And that gives us our two solutions. That's number 1, and that's number 2. All right, and so that, remember, just kind of think about that. Let's do the sign to kind of make the connection here for a second. All right, so we know that we're looking at the sine of x is equal to 3/4. So that means that on this graph, we're positive 3/4. So we're about approximately right there. Okay, so we can clearly see that that means we're going to have a data value right here and a data value right here inside of our period of 2 pi, right? So that travels 2 pi. Down here, this doesn't count because they're negative values. We don't have a negative, we only have a positive. So we come back to this, we say, all right, well, negative 3/4, positive 3/4. So we can take our calculator, we say inverse sine, sorry, I hit the wrong button, inverse sine of 3/4. We find out that the answer is x is equal to 0.84806. Now, the thing about this one is that in this case, we don't need to really concern ourselves with the 2 pi because in this case here, we've traveled this symmetrical distance. So we traveled from here to here. Now, since this is a symmetrical graph, that means we actually are looking for the distance from there to there. Well, this value is pi. So we're not going to do 2 pi. We're going to do pi minus our 0.84806. So we come back over here, we check this out. So that means that our x is going to be equal to pi minus 0.84806. So x is equal to pi minus that number, and we find out that our other solution would be 2.29353. So those would be our possible solutions. Now, obviously, that's inside of that interval of 0 to 2 pi. If we wanted to continue to do that, that's why we see that we see Hawk's Learning adding on that thing where they're adding on the 2 pi or 2n pi, because they're saying that this will cycle every pi, right? So every integer pi. All right, so I think that's going to help us. Please let me know if there's